welcome you all in this new video, and this video is going to be very interesting because why we are going to discuss about the Zeeman effect. Okay, this is the very important phenomena or effect of the quantum mechanics, because this experiment or this effect shows us what is the nature of atom, okay, when it is under the external magnetic field. Okay, and when there is external magnetic field and atom is under it. Okay, so which kind of behavior is shown by that atom? Okay, so we see that there is a spectrum, okay, by the excitation of the atom. Okay, and that spectrum split into further spectral lines, means when that spectrum come under the influence of a particular magnetic field, okay, that spectrum increase. Okay, whenever that will increase, when the spectral lines inside that spectrum will increase, means there is spectral lines production when atom is under a particular magnetic field. Okay, so Zeeman effect has its own significance in the quantum mechanics, and so because this is about the atom, okay, and show the effect of external magnetic field on the atom. So it is also very important to know us how atom works, okay, and how atomic sorry magnetic field is inside that atom. Okay, so basically what was that, and we are talking about the Zeeman effect. So an experiment was conducted by Zeeman in 1896, okay, where he experienced or studied the interaction of atom with the magnetic field. Okay, and while this interaction, he saw that there is an excitation spectrum, okay, which is formed when it is under magnetic field, and when it compared with the spectrum when there is no magnetic field, he saw there is huge difference. What was the difference? He saw that when there is a spectrum, okay, when there is no magnetic field in the atom, let these are the spectral, there are three spectral lines, and then there is another spectrum of that particular atom, okay, which was initially we measured when there is no magnetic field. When there is magnetic field, let in this case there is no magnetic field, B is equal to 0, and in this thing B is equal to, let's B1. Okay, so it has some magnitude. In this condition, what happened, he measured that there is large number of spectral lines, and then he observed that when a particular atom is under external magnetic field, then that spectral line split further into its component. Okay, and these component had some difference in the wavelength from the original spectral lines. Okay, so this is Zeeman effect what he had experienced. Okay, so this was the experience he experienced, that external magnetic field, okay, in the presence spectral lines what split into a number of discrete lines, means its component like this is your spectral lines when there is no magnetic field on the atom. Okay, and this is the condition when it is under the influence of external magnetic field, means this single spectral line split into three different spectral lines, and these lines have difference from their original spectral lines. Okay, it will be in dv d lambda, okay, whatever, means there is certain definite difference between these spectral lines in terms of the wavelength or frequency. Okay, so first we have to understand how it is possible. You know that there is atom, okay, and the atom contains electron which is revolving around the nucleus. Okay, because when they are revolving, they constitute a current, and that current motion produce the magnetic field. We know this thing, okay, by the thumb and rule. Okay, we know this is the concept of electromagnetism. What happened, atom have electron, okay, electron when move around the nucleus, they produce current, and current also dealt with the magnetic field. Okay, there is the production of magnetic field, and when that magnetic field of the atom interacts with the external magnetic field, okay, which is applying from the external source, okay, then there is this change. Okay, then there is splitting of the spectral lines, means one spectral line is split into more spectral lines. Okay, two or more spectral lines. So this phenomena is called Zeeman effect. Okay, so this is the outer look of the Zeeman effect. Okay, how you can measure the spectrum and the splitting of the spectral lines. Okay, and this is the actual inner diagram. Okay, so these are the poles, there are poles placed, these are electromagnets. okay, these are electromagnets and these are connected with the electricity source. And one advantage of electromagnetic source is that you can increase and decrease the magnetic strength by the variation of current, okay. So this is S, okay, here is your source of the atoms, okay, and here observer from the perpendicular, that this is the direction of magnetic field, and if you are standing here, okay, this is perpendicular to the magnetic field. If you are observing here, and this is from the, sorry, this is talking, so this is from parallel view, and from here you will see the perpendicular view, okay. So this is all about the diagram. So these are the electricity wire, okay, which is connected with the electromagnet, okay. So we know that Zeeman effect have two types, okay. First one is normal Zeeman effect and another one is anomalous Zeeman effect. The difference is that only there in the normal Zeeman effect there is splitting of one spectral line into three spectral lines, okay. Only this is the difference. And if we talk about the what is the difference in anomalous Zeeman effect, you will see there is the splitting of one spectral line into four and more spectral lines, okay, when we are observing from the direction perpendicular to the magnetic field, okay. This is the case, magnetic field, okay. So when the spectral lines is splitting into the three component and you are observing from perpendicular, this is your pole, this is your pole, okay. From perpendicular of the magnetic field, you see that one spectral line is splitting into three spectral lines, okay. And when that spectral line is splitting four or more spectral lines, then that at that case you will see anomalous Zeeman effect, okay. So now we will prove this thing, a classical theory of normal Zeeman effect. What did we will prove? What we will prove, okay, we will prove that there is a spectral lines and that is splitting into like this three spectral lines, means its component, okay. And you know, if there is spectral lines, it will have some frequency or wavelength. Let the frequency of this original spectral lines is lambda, and this spectral lines will be minus d lambda, okay. This will have lambda plus d lambda, means what, there is equal difference of these two spectral lines from their original spectral lines because their wavelength difference is d lambda, okay. So means what, we have to just derive an expression for this d lambda, because d lambda is also known as Zeeman shift, okay. Zeeman shift means how much difference is there in the spectral component, okay, that is formed by a splitting of a particular spectral lines. That particular difference in the wavelength of the spectral lines, okay, is called Zeeman shift, okay. And we will derive the expression for this d lambda, which is the wavelength difference between the spectral lines, okay, by the classical theory of normal Zeeman effect, okay. This theory was given by Lorentz, okay, on the basis of electronic theory, okay. And he said that electron having the angular velocity this omega, okay, v is the linear velocity and moving around the nucleus in a perpendicular, b is perpendicular in the direction, okay. Electron experience and force because of its magnetic field, okay. You just see here, this is the expression that we are, okay, we are going to derive the expression for difference in the wavelength these spectral lines, okay, that is d lambda, okay. So what we have to do, first we have to do centripetal force. This is the force when there is no any kind of the magnetic field, okay. Let this is the atom and this is nucleus and this r is the radius and e is the charge on electron and m is the mass of that electron. So what is centripetal force? Centripetal force is the force that is required by the electron to revolve around the nucleus, okay. This is the force that is required by any circular motion body, okay, which is moving in a circular motion. What is that? F is equal to m r omega square, okay. R is the radius of that particular orbit in which it is moving and omega is the angular velocity, okay. So this is the force when there is no any kind of the magnetic field. Now we are under a magnetic field. Let your atom is, this is your atom, it is under a magnetic field B, okay. It is under magnetic field B, so it experiences a force, let F1 Okay, that is a magnetic field, BeV. V is the velocity, linear velocity, okay, with which electron is moving. So what happened when this force occurs in the atom, okay, and experienced by atom, there is an increase in the angular velocity d omega. Okay, so now we have two forces, and now combining these two forces, okay, so we will get F plus F1 plus minus F1 is equal to mr omega plus d omega square, because d omega is the increase in the angular velocity. Okay, so you have to put this thing here. So what is the value, why we put here plus minus sign? This is because direction of the force will be inward mean toward the nucleus or outward from the nucleus. Okay, so this represent mainly the direction of that thing. Okay, and the direction of the magnetic field also impact the further things. Okay, so this is the increase and decrease in the things we will measure on later. Okay, so F is what, centripetal force mr omega square plus minus BeV is equal to mr omega square, I am expanding this, okay, plus mr d omega square plus 2m r omega d omega. Okay, so this is the expression that we get this term get cancel out. Okay, and this is also neglected. Why? Because there is d omega square. D omega is very small quantity, okay, very small in magnitude, so we will neglect this thing. So the remaining part that we have, okay, that is plus minus BeV is equal to 2mr omega d omega. Okay, this is that what we have. So now we are doing what, we will put this thing further on the chart. Okay, B means magnetic field, don't be confused here. Okay, so now we have what, d omega is equal to plus minus BeV over 2m. Okay, now look here, what we have d omega. Okay, d omega means what, there is the change in the angular velocity that comes out in the atom because of the external magnetic field. Okay, and now we can change this d omega is equal to d nu. D nu means nu is the frequency. Okay, so what is the relation between omega and nu? 2 pi nu. This is the relation between omega and nu. Okay, if we differentiate it, we will get, wait a minute, why this is stucking. I'm sorry for this interruption, okay, because this is lagging, that's why I have to stop it sometimes. Okay, so I was telling you that there is a relation between the d omega and frequency. Okay, wait a minute, yeah, so when we are going to differentiate it, this will become d omega. Okay, by putting this value here, we will get d omega, I am putting directly. Okay, this plus minus BeV over 4 pi m. This dV is the difference between that spectral line's frequency. Okay, and means this is the original lead, this is V, and this is another two spectral lines, so there will be difference of dV. So V minus dV, sorry, V, this is nu. Okay, I'm sorry, this is nu. The nu means which represent the frequency. Okay, this means d plus dV. Okay, now this is the difference between that spectral lines in terms of the frequency. Now change these terms into what, in the form of wavelength. Okay, what we have, dV is equal to plus minus BeV, sorry, EB, we have only E, this is not included here. Okay, we have only E and B, make sure it, there is only V because V can cancel out. Okay, so we have only this term, so we have EB over 4 pi m. Okay, now we know what is the relation between the wavelength and frequency, that is nu, C equal to lambda nu, and nu will be C over lambda. Okay, when we will differentiate, this will become dV minus 1 over lambda square d lambda. Okay, so this is the differentiation that we had by putting this value in this expression, final expression for the difference in the wavelength, okay, that we have. Okay, that will be equal to what? Minus c over lambda square d lambda equal to plus minus eb over 4 pi m. This from here we can easily calculate the value of d lambda. Okay, so that will be equal to plus minus lambda square over c eb over 4 pi m. This is the difference. Okay, this is the difference in what? This is the difference in a wavelength between that spectral lines. Okay, so by this expression we can